Although the course our workshop on the 90 degrees band is complete, but I thought that I should be giving you post processing techniques for this 90 degrees band. You might have seen these pictures in many papers. Okay, so as you know that for this band the flow is coming in the long pipe and then it crosses through the band and then it goes to the bottom side. Okay, so definitely the flow downstream of this pipe would be very important. Okay, so let me make the few planes here. So first plane I would be making is at x is equal to 0. So, and before that go to view menu and click on the compose, and from here click on the wall number 2, click on display and uncheck these options and click on apply. Okay, and also make it transparent. So what will happen is that we didn't select the outer faces, so outer face which is here will be not displayed. So some portion which is on the screen will not be displayed and the back side will be visible. And similarly you can click on the band and do the same thing. Okay, and similarly for the wall number 1 you can do the same thing as well. Okay, now we are going to make a few planes on the downstream pipe, that is this pipe over here. So from the results menu click on create and then click on isosurface. So we have to create a few planes here, and this is along the x-axis. So click on compute and it is from minus 0.025 up to the point 2. So be careful here, very much careful here. And typically speaking, this should be the start of band should be 0, but since there is some part which is over here in the S5, we are getting the minus 0.025. But we are going to create a plane on the 0, and so let's say this is plane number 1. Okay. Okay, and if you go to the display, mesh display, you can display this plane over here. Before that, I'm going to again go to compose and click on overlays. So overlays means that the previous thing which is displayed already will be remains there on the screen and will not be replaced by the new graphics. So I'm going to display plane number 1. This is over here. Okay, so plane number 1 is over here, exactly at the end of the band. And second, I am going to put maybe somewhere here. Okay, so this is plane number 2. Create, and third, let's say, is over here. And meanwhile, display these all the planes which we are right now creating. Next one is over here. And similarly, fourth one is here. Okay, so four planes are okay for post processing, but you get the idea that how to create these planes. Okay, so creating these planes and then displaying results on all of them 4. So now you can create more planes like 5, 6, 7, 8, 9. Okay, so now I will be not displaying these planes. So simply go to compose menu, and from here you can delete all these parts from here. Okay. Okay, now I will be going to the results, and from here I will click on the first on the vectors and uncheck global range, and I want to display the velocity vectors, and in the vector options I will select them of in the plane. Okay, in the plane. And second thing is that Okay, that's okay. So it will be on the in the plane and will not be three-dimensional. This will be two-dimensional vectors now. Okay, and also I want to make them arrows, and now you can display them on these planes. Okay, so you can see that we have the one vortex is being the flow is pushing towards the inner core from the outer side. So outer side pipe radius, the flow is being pushed inside. You can see this thing very clearly, and same thing is visible here. Uh, this is the case where we have the curvature ratio is equal to 2. But if you go below this curvature ratio, you will see that there is a more strong secondary flow. So I can, if possible, I can show you. So this is a case with the curvature ratio is equal to 2. So second case I'm opening right now, and that case is transient problem. So I will show you results also on the same planes or maybe close to these planes. Okay. So if you make the scale is equal to 2 here, you can see this flow in a better way. Okay, if you display only on the single plane, you can even get the better idea. Okay, and you can also see the boundary layer flow along the walls, and the mesh is very refined there. And now the next thing is that I'm going to create a one isosurface just upstream of the this bend. So this is going to be the along the y-axis, and along the y-axis, so compute, and it is almost at the end of the bend. Okay, so from here I'm going to release the path lines. So from the plane, that is the y coordinate. Okay, initially I would be skipping maybe 20, so this will help me to see that the sometimes if you release more path lines, this can make the problem in the displaying, and your computer can freeze for some time. So that's why you start with some skipping, and once you are satisfied that okay, this is okay, then you can reduce the number of paths skipped from the displaying. Okay, so now the 20 are okay. So means that 20 paths are skipping and others are here. So now I'm going to increase the width of the line to get the more proper view. Okay, like this. Okay, now I'm going to back to the view menu, and from here I will click on the compose, and I'm going to delete these vector plots. Okay, and I will go back to the vector plots and select all these 4 planes, and click on the vector options, and from here I'm going to choose the black color, so I can see the vectors while I'm displaying the other things here. Okay, so now you can see this view very clearly. So you can see that flow is going in this way. There is a vortices, but they are not very strong. Okay, since this flow is not going beyond this point, you can increase the size of the steps. So if you increase size of steps from 500 to 1000, these path lines will go further. Okay, so now they are going further. So basically the step size into the step will equal to the length of that particular geometry. So the step size is for example here is 0.01. Okay, so initially there were the 500, so it can go up to the 5 units. Now if you make them 1000, now they can go up to the 10 units. So that's why now we are getting the path line in the complete pipe here. Okay, and now I'm going to and also you can see that we have the extra path lines here. You can delete them from here. Okay, so now I'm going to display contour plots for the velocity here. Okay, so velocity will be x velocity, and on these 4 planes, and it should be local range. So uncheck global range and click on display. Okay, and from the color map option, I'm going to choose the arrow. So this will give you the better idea. Okay, and I'm going to delete the path lines so that I can have the proper view of vector plots and as well as the contour plots for the velocity. So delete the path lines. Okay, now you can see that uh, we have the reverse flow here and we have the vortices being formed here. So they are little vortices, but they are still being formed there. Okay, now if you go to the second case where we have uh, in this case the curvature ratio is 1. This is the topic of the next workshop, but I'm just showing you the difference between these two graphs. And here you can see the almost same planes, but this is the result with the case where we have the curvature ratio is equal to 1. And this behavior is basically is changing. It is like sometimes this vortex is over here, sometimes it is shifting on this side, sometimes it's going up, so it's not stable. But if you take a look on the curvature ratio of is equal to 2, as I told you, this is a steady state case because the flow is not changing. If the flow starts to fluctuate, and so the residuals will start to fluctuate also, and this indicates that the results are the case is like unsteady. So then we have to solve this case as unsteady, like we have to set the time step like these things. So, but for the curvature ratio is equal to 2, we have the two vortices like on the two sides, and these are two counter rotating vortices. They are on the two sides and they are fixed in the time and space, so they are not moving. So that's why this case is stated as a steady state, but with the curvature ratio is equal to like a 1, which is less than 1.5, the vortex is fluctuating in the time and it is changing position with the space and the time at the same time. So you can see the flow like this. Okay, and if I display the path lines, you will see this thing more noticeably. So this is the plane from which I'm going to basically release the path lines. Okay, so delete this y coordinate. Okay, now from the results menu, I'm going to select the path lines, and these path lines will be released from the y coordinate. 20 will be skipped, and this will be the line attributes are equal to 2. That's okay. Okay, save display. This should be from here. Okay, I can delete the one extra path lines from here. Okay, you can notice the difference here. The flow is having the very strong vortices. So I can compare side by side. Okay, so here we have the, now from the results, let me display the path lines, and I will release them from the y coordinate. I will be skipping 20 path lines. Okay. So here you can see that the flow is not that much 3D as in the case of when the curvature ratio is equal to 1. You can clearly see this thing over here. Okay, so this was all about the post-processing. This is the additional video. I wanted to give you this idea that how to post-process these results and show the results in this way. So this is the case where we have like the curvature ratio is equal to 2. And the second case is the case where we have the curvature ratio is equal to 1. and this is the clearly a transient case. So now you can, I hope that now you can show these figures to your audience in a better way. Okay, thank you for watching this video, and if you have any queries, you can ask me question anytime.